Welcome back, Algebra. Let's go ahead and get everything that you need. We'll get started. We're going to continue with new content. But before we continue with new content, let's answer these 3 questions in writing. Go ahead and pause the video, read those 3 questions, answer them in as complete full sentences as you can. Even if you don't know, just try something, put down what you think. And then when you are done with that, you can unpause the video and we will move on. In this video, we have so many definitions and vocabulary, and unfortunately what that means for you is there's a lot of notes taking. The reason I make you take those notes is because that's a way to actually learn it. There's something to be said about using your mind, having it go down your arm to the fingertips, and then putting it on paper. There's a way that it really connects with your brain as something new and something that you are learning. So we're going to learn those definitions and that vocabulary to define things like vertex, domain, and range. We're going to notice some patterns, and we're going to figure out this whole graphing situation with absolute values. Okay, before we begin, make sure that if you are taking notes in the OneNote here, that's amazing. You can do that and use that as part of your assignment. Sometimes that's a little more difficult. So what I do encourage is that you do this on a piece of paper instead of on the electronics. However, you have the freedom. Decide what you'd like. All right, take a moment, and if you can answer what those things are because you just know what they are, go ahead and try that. But I'm going to go ahead and I have the definitions typed, and I will put them in its place, and we'll discuss them. Remember in our last video, we talked about what that absolute value definition is, and really what it comes down to is it's the distance away from 0, and distance is always positive. So absolute value is absolutely positive, absolutely. So that's something that's that catchphrase that I came up with in that last video. Hopefully you have something like that for you. Okay, make sure that you have that definition written. A function is when every single input of x has exactly one output of y. So really what that means is if I have a point here, my x value is 2, my y value is 1. I cannot in a function have an x value of 2 and another y value of positive 2. Because I have 2 different outputs for the one input, that is not a function. So the way I like to remember it is that for functions, you can never ever repeat your x values. But if you think about it, why on earth would you ever want to repeat your x anyway? The reason they're your ex-friend or your ex-boyfriend or your ex-girlfriend or your ex-significant other, the reason why they're your ex is for a reason. You don't want to repeat those. So just like in real life, in a function, you do not want to repeat your x values. So a function is any graph where you have each input has just one output. And again, you can't repeat those x values. So a parent function is the most basic graph ever. Like there's no bells, there's no bows, there's no whistles, there's nothing pretty about it. It is absolutely as basic as can be. We have seen an actual basic graph or parent function before when we have done linear functions. We have seen y equals mx plus b over and over and over again. We have used that y equals mx plus b when we have done slope, when we have done the y-intercept, we've defined all of those parts, but when you come down to it, when you come down to the most basic part of it, we are talking that y and x are the most basic parts of that, correct? When we have nothing for a slope or we have nothing for a y-intercept, we would just have y equals b. I want you to notice that we rewrite functions where that y becomes f of x. And I say that parenthesis there, we say the word of. It's f of x. So it's the function of x. That's really what that stands for. The parent function of just a line is a line that has a slope of 1 over 1. It's positive, and it goes through 0. And the reason it's like that is because we have y, or, and from now on I'm going to write it f of x, is just x. We have 1 in front of that x value. That's how we know the slope is 1. We have no b value given, so that's how I know I started at that origin. So the parent function of a line is just a line that goes through the origin. Well, the same is to be said for the parent function of an absolute value. And again, that equation for the parent function of an absolute value would be the function of x equals that absolute value of x. And the way that looks is that it starts at 0, 0. An absolute value is always positive. So that means from 0, 0, it's positive. An absolute value is always in the shape of a V. Don't know why that works out that way, except that when we do things with tables, you'll notice that it works like that. But the absolute value function is a V. So that's how it would graph. The parent function starts at 0, 0, and then it climbs up with a slope of 1 or negative 1 on both sides. We'll explain here in just a minute. However, take a moment, pause the video, make sure you have things drawn in, all of your definitions are there, process it for a second. That's a lot of information we just went through. Okay, so again, we can see on this next graph, you're going to take a moment, and on your paper, you're going to write a graph or sketch in a graph that has things that look very similar to this. We're going to use these 3 graphs, these 3 absolute value graphs, to determine some things about them. All right? So the very first thing I want you to notice is that our, sorry, I did not make an arrow like I wanted to. I looked at that and went, what did I do? This is that parent function. Right? That's the absolute value parent function. And I'm going to write it as the parent of f of x is the absolute value of x. All right, when we have this, the domain is any value x can be based on that graph. Any value x can be based on that graph. So if you look at our drawing, any value x can be based on that parent function, based on our parent function here. X can be 0. Yep, x can be 1. Yep, x can be 6. Yep, x can be, what if we went all the way out here to like 427? That graph eventually would reach it, right? Like it would go all the way off the screen somewhere way up over there, and it would actually become something that's on that graph. So of course, x can be anything in the positive. We can look at it and say the same thing on the other end. X can be any negative value. X can be negative 6. Yep, it's on that graph. If I went past there, if I went to x equals negative 10, if we were to continue that graph up, eventually it would find a point where x is negative 10. Totally fine, it's a part of it. So what's that word that we use that can be everything? Any number, always. Well, we like to call that infinity, right? It's an infinite value, an infinite amount. And we write these with intervals. So the domain for any value that x can be would be that negative infinity, because it doesn't matter what we want it to be, and at positive infinity, because again, x could be any positive value that's up there. So it's any value that x can be based on the graph. And notice that I used parentheses. I'm going to use the same brackets or parentheses that I did for inequalities, which is why we learned those inequalities first. Okay, now that we know that domain is anything that x can be, can you guess what a range would be? Well, if you guessed that the range then is any value y can be, you're absolutely right. Domain is our x's, ranges are our y's. This is good. So any value that y can be. If I look at the y-axis, I have +1, +2, +6. I'd have +7. Can I go up and up and up and up and up and up and up until infinity? Absolutely I can. I know that y can be any positive value. However, based on this parent function and this range, look at down here. On that parent function, do I have a point that goes right there? I don't. So it can't be -1. On our parent function, do I have a point that goes through -5 anywhere? I don't. And that makes sense because an absolute value is positive, correct? So the way we would write that is that we would say our interval is 0. Can it actually be 0? Yes. And because it can be 0, we put a bracket. We then say that it can be any positive number all the way up to positive infinity. Okay, again, that's a lot to process, so take a moment, process it before you move on. A vertex then is any point or one point where two or more lines meet and change directions. So if I look at my parent function here, I'm going in a negative, 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 negative. Ooh, I stop right there at 0, 0. And now I'm going positive, 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 positive. So where those two lines meet, that point where they meet is called the vertex. And in this case, on our parent function, it's 0, 0. This case, it's 0, 0. So our vertex is a point, correct? And we know that points are always written in x, y. But for a vertex, we actually call it HK. And you're going to find out later why we like those letters instead. We will use them later when we actually are talking about the formulas themselves and the basic parts about formulas themselves. So we need to have different letters because if we had two X's in there, it gets really confusing. So the actual vertex is HK. Now, as you had noticed, I talked about how on our parent function, we went negative, 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 negative. So in reality, this portion right here of our parent function, that is decreasing because it's negative. So our decreasing are negative values, which would mean that our increasing portion is anywhere on that absolute value graph where our slope is positive. So to sum up those rules, we're talking about that an increasing portion of the graph is when the slope is positive, and a decreasing portion of the graph is where the slope is negative. And what we do there is we write them again in intervals, just like we did above for domain and range. So where our absolute value is going in that negative direction, that's going downstairs, we know from the x values, it goes from negative infinity. Wow, that was an ugly infinity sign. Plus, you can't reach it. It goes from negative infinity. Ooh, again, ugly. Sorry. Negative infinity. There we go. To 0. And does it include 0? It does, so I'm going to make it a bracket. This is where it's decreasing. Where it increases then, we would say is this other direction, right? It goes from that 0, 0 all the way to the positive. So again, it includes 0 and it goes all the way to the positives, any values of x's that are there. So that's what we are talking about when we're saying is it increasing or decreasing. And again, we write intervals. We write them in terms of intervals, just like we would for the inequality symbols. That was a lot. Did you take it all in? Whew. Here we go. All right, we only have a little bit left, and so then we're just going to use these as examples. I'm going to look at our purple absolute value. For the domain of that, remember, in our purple absolute value, what are the values that x's can be based on that purple graph? Well, it looks steeper to me. It looks a lot more narrow to me, like it just is a thinner or narrower V. But I know that again, if I were to even go all the way over here to -3, eventually my line would hit it. So my domain for absolute value is negative infinity to positive infinity. My range for that purple is going to change a little bit, because if you notice, that vertex hits right there. That